although the textbooks like to use the term poor experimental designs, probably pre-experimental designs or non-experimental designs is a different and better, more appropriate term. So, most of the time this involves when we can't control all those threats to validity, we don't really know, if our outcomes are going to be valid, and especially if we have a non-random assignment. So one-shot studies. So you only see participants one time. You're not giving them any pre-test, post-test. So for example, with a survey, you're going to get just one shot. So if X is your treatment, you're going to administer your survey and you're going to get your results. And there's very little that you can do with that. You might be able to do your descriptive statistics, mean, median, mode, frequency data. You may be able to do some non-parametric analysis like chi-square that we're going to cover. So you're very limited in the type of analyses that you can do. When you have one group and you measure them, you give them a pre-test, so you do a baseline assessment and you administer your treatment program, your independent variable, and then you test them again. So again, one group pre-test, post-test. That is a very common design. So you can see there's no control group, so everybody gets the treatment. So typically we're going to do a t-test, and a version of t-test, and we'll cover that, a dependent t-test, because we have the same people measured twice. For any of you who teach classes, say in the aerobic walking or in our activity program, we will measure the students at the beginning of the semester, have them do a 1 mile walk time. They obviously do their activity during the course of the semester, and then we measure them at the end of the semester to see their improvements. So static group comparison designs, non-equivalent control group. I know that sounds like a lot of mumbo jumbo, but this is very similar to what some of us are going to do. So it's not again, I don't like to call it poor, it's just non-experimental. We're using two intact groups. So that is what we're already using. We don't have a random assignment. We don't have a control condition. And so this can be affected by subject characteristics. And if you remember seeing the data from Laurel's study with the interaction and how we had the potential effects of repeated testing, you can see why that could be. So it's can be affected by the different subject characteristics especially. So again, static group pre-test, post-test. So this is where the change score, we use a change score. So you do a pre-test, post-test, only one group gets the treatment, but we're going to look at the effect of change. So we're going to see how much they improve based on the treatment. So it's just the effect of testing, and once again, this gets, this is similar to what Laurel did, but she did not have a control condition. All her conditions got the assessment. So now we'll get into experimental designs. Randomized, post-test only control group designs. Okay, so this is where we've randomized the subjects. We've got two conditions. So the X means one group is getting the treatment, one group is getting the control, and then we're going to measure that. So I mean, what's really nice about that is going to be our independent t-test, because we are not testing the same groups of people. So it's a t-test. A t-test is used with only two groups. So by doing this, you don't get the effects of repeated testing. It minimizes the effect of the subject characteristics on the testing, but you do have to be worried that, are you going to be able to test everybody that you need to test? The randomized pre-test, post-test control group design. So you randomize the participants, you do your first testing, then you implement your treatment, and then you have your control, and then you test again. So this is a really common design in our field. So there is a pre-test effect, but we've got the randomization, and we want to look at measures over time. So this is called a repeated measures. So repeated measures analysis of variance, or repeated measures ANOVA. And it looks complicated. It's not that challenging, but we have a lot that's very similar in our field that uses this type of design. So very common: exercise science, athletic training, sport management, teacher ed, where we're going to measure people, randomize them, and then we're going to do multiple assessments on them. So pre-test, randomize, get the treatment, follow up, post-test, follow up 1, follow up 2.